How would we ensure that the processes we have are in control? Let's see how statistics can ensure the monitoring or procedure of processes that we look at. Statistical process control, or SPC for short, is the use of statistical analysis to see whether a process is running how we want it to. This is a pretty broad topic, and contains much more detail outside of the scope of this few-minute video. So, what kind of statistics goes into monitoring a process? At Bell Laboratories in the early 1900s, an engineer named Walter Schuhart started analyzing processes and came up with control charts. Control charts basically tell you whether a value that represents your process is something that you would expect out of it. When we say that a process is in control, we're saying that measurable data from the process does not go out of bounds of our control limits. These limits represent a certain probability of a value breaching that limit. If in our process that limit is exceeded, it is grounds to assess whether that output was a result of an out-of-control process. Control charts are sometimes thought of as a distribution turned to its side. Because the probability of a value breaching one of the control limits will be very low if implemented properly, any recorded value outside of the limits is grounds for investigation. Whenever we come across an out-of-control value, we may either investigate the process and see whether the value has a cause we can fix, or implement an advanced process control loop. Advanced process control loops are a set of automated procedures that self-correct the process. This means that we must know how to correct the cause of the out-of-control variable, and is something that can be employed by an engineer. For example, if we have a computer system monitoring the status of a roller coaster, the sensors will monitor things like the status of trains on the track. If one of the sensors detects something out of the ordinary, it is likely the fault of the sensor and not that a train is missing. So, to be safe, the computer system would react as an advanced control loop and reset the sensor. If the problem persists, it is grounds for an engineer to look at it before the ride can continue operating. The Industrial Revolution started in the late 1700s, but statistics were not widely used for quality or process control until the early 1900s, thanks to Walter Schuhart. Since then, it has been increasingly common to perform statistical analysis to ensure operations are smooth. SPC is being implemented in businesses and engineering firms in modern times to ensure the efficiency of production or productivity. One popular method of applying SPC is Lean Six Sigma. This is a combination of two original ideologies combined into one. Lean, one of the original methods, was developed by Toyota in the 1930s and focused on minimizing waste. While working for Motorola in the 1980s, Bill Smith created Six Sigma, which also minimizes waste. The name comes from the fact that if implemented correctly, 6 standard deviations, or 99.99966% of outputs of a process would be acceptable. Lean Six Sigma has been implemented into major companies such as Texas Instruments to save money and time by reducing waste. Nowadays, you can be certified in Lean Six Sigma. Overall, SPC is a wide variety of methods to locate causes of unacceptable output from a process, and some methods even offer insight and solutions to the problem. When applied correctly, SPC improves efficiency and ensures less cost of maintaining a process.